we're going to talk about observability, and then so this picture, so we just bring that up. So there are some blind side between Kevin and I, like as a middle side. So you need to always to monitor and observe every single angles. So that's why we put on this kind of thing, and then go back to the first stage, right?
Yeah.
Just to remind the session title.
Yeah. Yeah. So this talk is going to be about, how can we do tracing, how can we have insight into our applications in distributed systems, right? And especially when we do serverless deployments where our applications scale up and down, we can't just go into the logs of the application because it may have scaled down before we have the chance to go and look into that. So let's think about observability and insights for a second here. So this is an old picture of my favorite soccer or football team, Lazio, and this player, Silvio Piola, was doing something here, but I'm not entirely sure because this is a long time ago, but we can kind of see some interesting things, right? We see the ball over there, so presumably he kicked the ball. Is he about to score? Perhaps. What is the guy behind him doing? Like, was there a foul? We have no idea, right? Because we have no way to go back. There's no video recording of this. There's no kind of data that we have to see what was going on, right? So we don't know. Now, maybe a little bit more relevant example for you here in India, right? So you do have, with modern technology, we have cameras, we have actual telemetry, and we have even smart systems that can see what exactly happened, right? So we can see if somebody actually hit the ball with the bat, or if it hit the shoulder or something and it kind of seemed like they did or something. We can go back and actually see whether it was a valid call or not. So that's kind of a similar evolution that we've seen in the software world, right? So for developers, back in the day, it was very hard to go and see what actually happened. Somebody says, yeah, there was a bug in the code. Okay, but when did it happen? What happened? How can I go and see exactly at what line of my code this error happened? So this is all kind of part of this observability that we need for our applications to support each other, right? So, how can we know that our application is healthy? What is the root cause of this error or defect? And perhaps also, like, what are some performance bottlenecks that we're seeing? Because if somebody says your application is slow, okay, where do we start with this, right? How can we see, was it the database call that was slow? Was it a call to an external system that was slow, right? So how can we see all of that? So we need observability. So in terms of observability, there are kind of three main pillars. On the one hand, we have metrics, right? So data that we can use. For example, in the Java world, let's see how long the garbage collector took to start picking up this component that wasn't needed anymore, or how long did this particular component take, or how much CPU is the JVM using, so all sorts of data that we can use to optimize our applications. Then in terms of logs, well, of course, like if we have some visibility into what our application produced, maybe we have some logging information to help us debug some systems. And then tracing actually helps us to go and see, if a call happened and it went from this service to this service to this service, how can we track it along the whole way and then nail down exactly where in this chain was there an issue? Was there, again, a performance bottleneck? Was there an error on what line of code? And so those are the three main components of observability that you should have in your applications, especially running on production, to be able to support yourself and hopefully not have long downtime or spend many hours at night trying to figure out what happened in your application. So there are, of course, many tools out there that can help you with this, and I'm assuming many of you are using some observability tools. And but so along those different pillars, we have different solutions, different applications, and different vendor solutions that can help us, right? So maybe for instrumentation, like to actually plug into your code, how you can externalize this data, these logs, the insights. You might have one solution. Then maybe to collect that data, you have another solution from another vendor. And then for the processing of that data, maybe you have yet another solution. And then to actually go and see what happened in your application with a tool, you might have yet another tool. So, and then especially if you're using proprietary code from vendors, that means that you need to find some way to make these all work together, right? So it can be a little bit of a complicated mess. So what oftentimes organizations will do, they'll say like, okay, we're going to go with one vendor for the whole stack, and the vendor is very happy with that, right? Because now you're very locked into that particular vendor, and it's very hard to move to another vendor. So, of course, it's a little easier, or maybe not easier, but better if you look into open source solutions. And the open source communities are pretty good at trying to help us figure out some solutions with open source. And then the vendors that have proprietary solutions, sometimes they're kind of forced to start using and adopting these open source standards and specifications and everything, which benefits us all, right? So now we can use different solutions, perhaps still from vendors. You don't necessarily need to use community open source. You can also use some solutions from vendors, but at least, you can have some open standards, which helps you, bring it all together. Now, there are, even in the open source communities, there are a lot of solutions and from vendors as well. And it becomes a little complicated, right? Because now you have to choose which one should I use, and they use all different protocols, and I need to make sure that it all works together, which, even if you're using open source, you could still have, hard time with your observability stack. So there were a few projects that tried to solve some of these issues in terms of standardization, making it into a community effort with different vendors involved. And one of those projects was open tracing. So, as the name kind of implies, it helps you with tracing through your applications. And so that's great. We have a tool for some standardization, but you know how it happens, right? We have 14 standards, and then let's add another standard because we want to try to consolidate things. And then, of course, now we have 15 standards, and that's kind of what happens, right? And so we also have another project that started, which was Open Census, to be able to do the telemetry of your applications. And again, another open source project using different standards, and now you have kind of two different projects that you need to try to work with, which is already kind of better because at least it's open and we can see what the protocols are and what the standards are. But yeah, we need to maintain now different standards. So let's come up with another standard, is what the community said, to try to simplify things. And that's kind of the idea behind OpenTelemetry, to have one standard, one specification for telemetry, for observability. And fortunately, OpenTelemetry has been widely adopted in the industry to do this thing. And so we see that many vendors are coming on board to support OpenTelemetry. So if you look at the CNCF projects here, so this is all the kind of CNCF projects that have been worked on in the last year or something. What is it? Between 21 and 2022, but it's kind of a similar story in last year. So we have, this is a small project that didn't have many commits, and that wasn't very popular, to all the way at the top, you see Kubernetes as, the project that had the most contributions and was most used. And actually, we can see that OpenTelemetry was the second most popular project in the CNCF landscape. So this really shows that there was a real need for industry-wide kind of standardization for doing telemetry and observability. So in OpenTelemetry, we have kind of three main goals, three components that we're looking at. So on the one hand, we have the specification, to have one standard specification for everybody to do telemetry, to use the same kind of cross-language application of how can I export my data into an observability stack, and with what protocol and whatever. And then on the second hand, the next goal of the OpenTelemetry project is to have a common instrumentation goal, so that you can have an OpenTelemetry instrumentation to work with Java or with Go or with Python or with Node.js. So, to have common set of instrumentation to do telemetry. And then lastly is to have a common kind of way to collect the data, right? So that we have different vendors or different projects that will be able to collect this data from OpenTelemetry, because it's the same spec, it's the same structure of data, and that allows us to have a lot more flexibility for us as users to switch from one project to the next. So we're going to talk specifically today about how we can use OpenTelemetry in that kind of serverless world where we're scaling up and down, and then specifically with regards to Java.
Thanks, Kevin. It's so informative and insightful. A little bit boring though.
Yeah, exactly.
So
we want some live demos in the.
Yeah, so let me give it a showcase of some of the live demo, how it works and what it looks like for serverless application. As you probably know, the monitoring observability on the application most likely stable, which means that you're going to run the application regardless of virtual machine bare metal of a Kubernetes container. It's already running all the time, 24/7. However, so technology keep evolving. Doesn't matter AI or edge IoT stuff. Your application can be evolving to serverless anytime because you reduce some cost as well as more optimization. So .NET, Java, Python, you can change your application serverless. It's like a deployment model in the new advanced cloud-native architecture. But in my experience with observability, or you can say monitoring, application should have some agent to communicate your application and then grab some data. You can say logging, tracing, or telemetry data, and send it back to your some infrastructure, put together all data, and then showcase the visibility. That is somehow that works in traditional way. But serverless is up and down. Like you got on-demand network traffic, it just goes up like Amazon Lambda, and then you have a node process, and then it goes down like a Hibernate. And then your agent, oh, where's my application? I have an offrun. So that's really happening. So you don't need to keep changing your application, some configuration, IP address or service IP or host name to find out your application. That's not a good way. So we're going to really bit talk about how to solve that problem. For example, the Kevin and we are Java champions. That's why I picked up Java application using Quarkus. And then OpenTelemetry, of course. And then serverless in open source way, the Knative project as a part of like a Kubernetes sibling. You can actually run your application as a serverless behavior on Kubernetes, like Amazon Lambda, Google function, and like Azure function, something like that. So just in case, I got to just quick question, how many people actually have some hands-on experience with the Quarkus before? How many of them have a hands-on experience with the Quarkus? One? I gotta accept the challenge today. So Quarkus is a Java framework, not compatible with OpenJDK, not compatible with GraalVM like a JVM. It's a Java framework like a Spring Boot. And then, so when we designed Quarkus almost 4 years ago, we are targeting developer productivity, which means that we're gonna help developer life easier and happier. So if you do something like a Java stuff, like a develop new application for 2 days, we help you out making happen in hours, like rather than 2 days. So Quarkus provides many great developer productivity features like a live coding, just like a JavaScript. You don't need to rebuild, recompile, restart application, and then you pretty much easier reactive application and non-reactive application development at the same class and the same method. And then there are continuous testing capability and an out-of-box feature or test container, like a zero configuration. You don't need to put any configuration for test container stuff. And then there are a lot of great features, CLI, UI, things like that. So I'm going to stop my boring presentation. And then here's my, where it's go, here is my IDE, where we go. There we go. It's too small. Okay, let me try to make it some bigger. Okay, hopefully some people see that. Okay. So this is a Quarkus project, and then very simple. This is like a REST API stuff. A few bunch of the REST API, like some like a hello world, and then put in some CRUD capability, like some data interaction. So here is some application, like some endpoint person, which he retrieve all data from database. I'm gonna using PostgreSQL, and then another REST API based on here the ID, which I just need to grab one specific data rather than all data, and then like some endpoint hello, some like a static text message, and then greeting with some welcome and some specific name, probably my name. And then go to application property, and then so for the one of the good thing for Quarkus, you don't need to manage multiple property file or YAML file for targeting environment. Here's my local, here's the testing, here's the production. You have a multiple property files to manage that thing. But Quarkus allows you have a pre-defined prefix like a %dev, %product, %test, or you can also create a % whatever you want, and then Quarkus automatically pick them up for specific target. When you run Quarkus dev mode, Quarkus only pick it up starting with the dev or just without any the key and values. Or when you packaging application, for example, Maven clean packaging or Maven clean install, Quarkus only pick them up based on product configuration. So that's exactly, you can see any developer environment configuration, only production for, here's my Postgres configuration, like a JDBC URL and a username, password, and then some of the other stuff. And then here is the Kubernetes deployment. So how do you deploy application to Kubernetes? It doesn't matter Java, .NET, Python. You need to containerize your application using like a container CLI, which is a Docker Podman. And then once you create a container image, and then you can push the container image somewhere, container registry like a Docker Hub or a Quay.io or some our Google Container Registry. And then what is the next step? You're going to create a YAML file for specify Kubernetes manifest, like a service deployment or the other stuff. And now you're going to use kubectl CLI to apply for that YAML file. You're targeting Kubernetes cluster, your own OpenShift cluster, or the Azure Kubernetes services, or Amazon Elastic Kubernetes service, or whatever you want. So there are a few steps as a part of your daily job. You can say outer loop, or you would say inner loop process. Whatever you call that, you need to do that. But Quarkus actually just automatically containerize the app, generate container image, and then push the container image, and then deploy the Kubernetes automatically, as long as you put in this configuration and the relevant library, which is a Quarkus extension. So pretty much easier. You're going to save your time for daily job, and then you're going to use the spare time, like some quick chat with us, or so go to watch the cricket game, or any kind of like a fun stuff you want. So I already deployed my application to Kubernetes, which is a Red Hat OpenShift. So one good thing, everybody see that. So Red Hat OpenShift, and then already provide a bunch of the operators, which allow you install some of the capability, for example, OpenTelemetry or the Jaeger server for tracing infrastructure, and then Knative also deployed by install and open serverless based on Knative project. So OpenTelemetry, you can define like a, let me go back to my project, and then here is the OpenTelemetry YAML file, like a CR, the customer resources. You can see that this is really the YAML file for like a little bit unfamiliar with the Java developers or application developers, but this is just some standard way, like Kevin mentioned earlier, like API SDK stuff. And then this is standard way to create OpenTelemetry collector, which actually grabs some old telemetry data and then send it back to your infrastructure. Could be Jaeger, could be Jenkins server, could be any like a tracing infrastructure. And then here is the Explorer endpoint. So I already deployed my Jaeger server using operator. So my Explorer server is Jaeger, which means the OpenTelemetry collector grabs some telemetry data from application and send it back to infrastructure, which is Jaeger. So Jaeger could be Explorer, could be the grabber as well. So it's all defined whatever you want. And then, so one more thing is the application property. And then when you deploy application to Kubernetes, and then Quarkus actually allow you targeting which Kubernetes, like a OpenShift cluster or vanilla Kubernetes or even Knative. So when you set up value Knative, and then Quarkus automatically generate YAML file, like a Knative YAML file under the target directory when you build application like a Maven build, Maven clean packaging or Gradle stuff, and then you can see that this YAML file automatically generated, and you don't need to use the kubectl because Quarkus already know the Kubernetes API, how to run that YAML file directly Kubernetes cluster. That's exactly I done that before, like a couple hours earlier. And then my application, this is a Quarkus application, as you can see, is scaled down to 0, just like the function behavior like Amazon Lambda, because the last couple hours I never tried to call this application. That's why I scaled down to 0. And then here is my Jaeger server OpenTelemetry, and it'll connect to my PostSQL database. This is a route URL to access my application based on fully qualified domain name. And then let me try to open my terminal window here. I'll make it bigger. And then try to access endpoint, for example, hello. And then when I go back to my topology view, and it really scale up just like a serverless behavior, and then go back to my HTTP request, and then I got a return. And then when I go back to Jaeger UI, and then you can see there's nothing in there like a serverless stuff. And then when I reload my Jaeger UI, it automatically detects my new serverless name, which is coming from this serverless pod name. And then create the operation hello, and then go to tracing, and I have one tracing here, and you can find the more detailed tracing data. So if I go back to terminal window, I'm gonna hit the one more time the same URL, and then when I try to tracing, it should be coming out 2 traces. And then I can also go to hello and like a person, and then I got a 3 data. I'm based on Boston from the United States, and then my friend Kevin from the Brussels in the Belgium, and then some other name, the Jen from the New York City. And then you can actually reload the Jaeger UI, and you can find the new operation here, like the person. And then you can find here, if I just needed to invoke the one, like a number 3, which is Kevin, definitely, and you can see the Kevin, and then you can actually load the operation, the Jaeger UI, and then you can find the new operation here automatically detected from OpenTelemetry. So what is the secret sauce? How OpenTelemetry actually keep checking the serverless application, which is up and down. Because when I go back to my application project, and then you can actually create the Knative service YAML file here, and then you can set it up some Jaeger as the endpoint, but that endpoint actually already connect to OpenTelemetry. So that OpenTelemetry not directly monitoring your application. However, OpenTelemetry monitoring your entry point, which is a Jaeger or a Zkin server, and then whenever you have some traffic happening for the Jaeger tracing stuff, and then OpenTelemetry just grab that data and then back to the your Jaeger server again. But I just using keep the both ways the Jaeger, but you can use any tracing infrastructure based on your production environment. So if we just give it a moment, and then application container is terminating right now because the Knative project has 30 seconds as a default scaled down to 0. So after 30 seconds, it will scale down to 0, just like Amazon Lambda stuff. And then when I hit the RESTful URL again, and then we're going to create a new container pod with a different name. So scale down to 0. When I go back to terminal window, and then let me try to new endpoint, something like a greeting. And then my application scale up right away, just like a server REST. And then now have a new return equal welcome then. And then when I go back to Jaeger UI, and then reload that kind of stuff, and then the pod name from the application. Here's a new pod name, end up with 266 SJ, and probably this one. You can see that, and then I just check it out, and then tracing data, and then you can see that no more hello person, the other endpoint. This is exactly just catching up new serverless pod from OpenTelemetry. So I don't have any change in my application configuration or OpenTelemetry side. So this is just some new standard way how to monitor stateful application as well as a serverless application with a multiple open source project. But I'm not going to say you always need to use Java or Quarkus to stand up this architecture. You can use any runtimes. Kevin already mentioned, that is a standard way, like a Polyglot, like a .NET, Python, and JavaScript, or like a Spring Boot, or Micron Halodon. You can use this architecture. The reason why, Kevin and why we created this demo within Quarkus, because Quarkus allowed us to save a lot of time to develop this application and deploy to Kubernetes as a serverless. So that's it, and then we're going to wrap it up. Thanks for watching and attending this today, and hopefully you enjoy the rest of the conference.
Thank you.